Alrighty, CNT140. We are working on Chapter 4, specifically on unshielded twisted pair. So some of this will be review of some things we mentioned before, but we're also going to be adding to that or filling in some gaps. So some refreshing is good, but also filling in some gaps on things about unshielded twisted pair. Alright, so for the most part, a lot of our cabling in a building, horizontal cabling and so forth, is your unshielded twisted pair. And it's because it's inexpensive. Many places have some already in place that you're using, but it's also it's familiar to installers. It's pretty simple to install. So it's one of those that has a lot of benefits. That's why we see a lot of it in a building for horizontal cabling. Some instances you might see shielded twisted pair or screen twisted pair. So we like to mention those. Shielded twisted pair, this kind of comes from the days of token ring, but with shielded twisted pair, you literally have a shielding around each individual pair. The thing I like to mention here, though, is we start seeing some of these aspects in our higher categories of twisted pair cabling. So we start seeing some of these aspects with the design of certain categories of cabling. There's also screen twisted pair. Here you have shielding around all four pairs. And again, this is the kind of thing you start seeing in our higher categories of cabling. So we should at least be aware of what they are. Our UTP and shielded twisted pair basically had its roots in phone system, plain old telephone system, where you had 25, 50, 100 pair cabling. Each pair was taking care of a phone line. So you had these large fan-out cables for handling multiple phone lines in a building, or multiple phone lines connecting buildings together or an area back to a central office and so forth. That's where our unshielded twisted pair, that's where its roots came from. So as I look at it, I typically see four pairs: blue, orange, green, and brown. And again, in some of our upper categories of cabling, we actually start seeing a plastic divider in the middle, separator in the middle, keeping those wire pairs separated to some degree to help reduce crosstalk. Well, we mentioned this before. We'll refresh your memory again. Our unshielded twisted pair that we use today has its roots in phone cabling. Here is the original type of phone cabling that got used. It was flat, non-paired cable. So this was able to handle, K of traffic, 14K kind of thing of traffic, 28.8 K of traffic. That's the kind of thing this was capable of doing. It wasn't until they started changing the structure that they could carry more data across that phone line. And that's when they started twisting the wire pairs together. As we mentioned before, twisting together helps reduce the amount of crosstalk, because it basically self-shields this pair from this pair and so forth. That's the twisting of the wire pairs together. Cables permanently installed on premise cabling are typically solid for the horizontal cabling, and typically stranded for your patch cables. So as I look in a system, as I look at my structured cabling system, the horizontal cabling that goes from the closet, from the patch panel in the closet out to work area outlets, is typically solid conductor. And as we said before, the solid conductor has less resistance, so therefore it's able to carry a signal stronger, if you will, for a greater distance. The trade-off is you bend this a whole bunch and this tends to break. So horizontal cabling is fine because I install it, terminating the closet above the ceiling in the trays and down into rooms. And once I install it there, it's pretty much staying there for 10, 15, maybe 20 years. It's not being moved. So this is perfectly adequate. Meanwhile, the patch cables that connects our workstation to the outlet or our patch panel to a switch, these tend to be stranded conductor. The conductor inside is made up of many smaller wires to make that, white-orange wire or the white-brown wire. That I have a lot of flexibility. I can bend it a whole bunch before it's going to break. So I can move that patch cable around. The trade-off, though, is this has more resistance. So it is actually going to resist the cable being sent through it. So you have to keep your patch cable limit within check, if you will, not make it long patch cables. I started installing really long patch cables in workstations. It might weaken the signal so much that you don't have a signal. Okay, that's one of the trade-offs of that flexibility. They remind us that our twisted pair cabling is paired, where you have a colored wire and a white color wire. These are coming from the days of phone where you had tip and ring. Those were the two wires that you had in a phone system, and those are coming from. And this is the trivia in here, but it's at least worthwhile to recognize. These cords that were getting plugged into the switchboard operator was plugging in to connect my phone to the person I'm calling. That cable had those two wires in the tip and ring, where the one wire is connected to the tip out here, the other wire was connected to this outer sleeve, this outer ring around the cable. So when they plugged them in, both those wires made the connection they need to complete the circuit. That's where the pairing comes from, the white and the colored wire, the tip and the ring. Again, unshielded twisted pair comprised of 4 twisted pairs of copper conductors. And they say here the secret ingredient is the twisting of the pairs. Yes. Plain old telephone, they're not twisted. Category 3, they're at least paired and gently twisted. But as we start going up in 5E and 6 and so forth, that twisting of the pairs gets more diligent and more precise, if you will. And you even find out that there is a slight different amount of twist, the number of twists per inch on like the white-brown pair versus the white-blue. That way, the magnetic field around the white-brown should not be affecting the magnetic field around the white-blue, a pair of cable. So that is one of they call it the secret sauce, if you will, of the development of these cables, the categories of cables over the years. So refreshing your memory, phone cabling, category 3. Category 3 was capable of supporting 10 meg. 10 meg here, category 3. As they increased the twist pitch and got more diligent with twisting, category 5, 5E, you were able to carry 100 meg and even gigabit. In the 5 and 5E looks very similar, but there is more attention to detail paid in the 5E, and even some of the quality of materials that were used in the cabling were a little bit better. So you're able to get gigabit speeds out of those. 100 meg for category 5, and gig with category 5E. As they wanted to put more bandwidth through, again, the structure had to change some more. Category 6, they're now adding a divider between the pairs, trying to reduce the amount of crosstalk or interference between the pairs, if you will. So with category 6, again, you're still able to do the gig, and as they did the 6A and start putting shielding around, this is your screen twisted pair, just the shielding around all 4 pairs, we're now able to dip into the 10 gig category. Able to jump into the 10 gig category. And they also mentioned category 8, which we mentioned when we talked data centers. This, you have a shield around all 4 pairs, but then each pair is shielded. So now they're able to get into the 25 and 40 gig category, but shorter distances, roughly 30-meter distance for these, for connections in a data center. A high bandwidth link, short distance in a data center. The key to all this, though, is keeping those twists intact as much as possible on these cables when you terminate. So as I look at the standard, the maximum amount of untwist I do before I can terminate is a ½ inch. That's the max that they're asking. They're saying you should do before you terminate the cabling. So that's something you try to work on as you're terminating, keeping that twist pitch intact as much as possible at the termination point. And as we do different terminations, I'll show you some tricks to help you do that. Our UTP cable is terminated mostly in jacks, outlet jacks, as well as punch down. So as I look at my horizontal cabling, okay, the solid conductor, this is typically terminated into the punch down in the back of a patch panel and on into an outlet jack that usually has some type of punch down mechanism with it. So if I look at the back of the patch panel, I run into these 110 blocks that I'm terminating into. And this is the style we'll see in the lab when we're doing our terminations. You'll line up the pair over the color bar for it, if you will, and we'll try to slide the pair over, then terminate it and punch it in. So one end is getting terminated to the patch panel, the other is getting terminated to an outlet jack like so. And as you look, this particular outlet jack style actually has a punch down in it, and you would actually use a punch down tool to terminate these in, just like you did the patch panel. The outlet jacks do have a color code associated with them, the order of wires that need to go. As I look carefully, I see a pair out here on the far left, a pair on the far right, and in the middle, those pairs are split apart. We have the blue pair in the middle and the orange around the outside. This is actually to accommodate phone wiring, that pin out here in the middle. So I could actually plug in a phone jack in the middle and use those middle wires, and the outer ones wouldn't get used in that case. But all 8 then can get used for data. So this pinout looks odd, but it was actually to accommodate phone cables. I could plug a phone into this, use those center 4 wires. But then as I unplug that and plug a data jack in, I'm using all, a modular 8-pin connector for patch cable on my computer. I'd be using all 8 wires then. So that is the pinout for outlet jacks. And if I do look at the side, they do have them marked as to what color wire goes where, depending on whether you're using the A or B color code. So as we terminate outlet jacks, we're going to be looking for that color code. And they're not all the same order on every different jack, if you will. You have to pay attention to the way they have it laid out so that the circuitry inside makes contact from this termination here to the pin out here. So we'll be following that closely. Meanwhile, patch cables are typically, they say here, typically factory assembled. Yeah, if you're doing a large install, you're typically going to buy all your patch cables and just, take them out of the wrapper and plug them in. That's typically what you're going to do. But if you have to make a cable, which we'll learn a little bit later, and sometimes you do, sometimes you need to make a cable on the fly, your patch cable is typically your stranded conductor, and it's going to get connected with a modular 8-pin connector. People use the RJ45, kind of like slang name, but it really is a modular 8-pin connector. That's something I learned out the hard way the first time I was ordering some of those. I wasn't finding RJ45, but I looked at modular 8-pin connector. I'm like, oh, there they are. So here, with our patch cables here, as well as over in the closet, we're using the stranded conductor, and I'm typically going to be terminating on this modular 8-pin connector, RJ45, connecting onto those. There is a specific order on this as well. Again, we have a pair on this side, we have a pair on this side, and then the 2 in the middle are split, like we said, to accommodate that phone wiring. Here's the T568A and T568B. The only difference between these two is the orange and green pairs flip-flop, if you will. So, with categories of cabling, here's like another refresher they talked about with category 3, 4, 5, and so forth. Category 3, its structure could support 10 meg or 4 meg token ring. Category 4 was developed for token ring to handle 16 meg, but not many places use category 4 because not a whole lot of places adopted, I shouldn't say not, token ring was not widespread adopted everywhere. It was in pieces and in parts. But as a side note, the college network at one point was token ring, just as a little side note there. Category 5 introduced to support fast Ethernet 100 meg. 5E was upgraded. You took 5 and upgraded it. We're able to get gigabit speeds across this, so they called it an enhanced category 5. Category 6 was developed with that divider in the middle, giving you better capability for gigabit. You weren't running so close to the limit of the cable. And then category 6A, augmented 6, category 6A, augmented 6 was developed to handle 10 gig needs. Category 7, they say here this was kind of like a Europe thing, not too widely adopted here in the US, but this was actually a shielded twisted pair version introduced to be used. What we do see sometimes is category 8, especially in data centers where they're not using fiber optic links. You might see category 8 connecting short distances again, 10 to 25, even 40 gig, but short distances. Okay, we come back in the next podcast. We will continue on.